Look closely at this photograph. Almost every point of light you can see is a star, an individual sun, and there are more than 60 million of them packed into this single frame. This is the most crowded region of our entire galaxy, the bright swarming heart of the Milky Way, and you're looking at the largest and most detailed photograph ever taken of it in visible light. A European spacecraft captured the whole thing in just over a day, but the sheer number of stars is not what makes this image extraordinary. Hidden inside it are dozens of alien worlds you cannot see, frozen planets circling distant suns, including the one that an astronomer has waited 20 years to weigh. And the photograph itself is something stranger than a picture. It is a message, taken deliberately now, for telescopes that will not need it for years. Let's take a deep dive into what they really captured. To understand what you're looking at, you need to know the telescope that took it. Its name is Euclid, a European Space Agency mission launched in 2023, and almost everything about it is for the opposite of this image. Euclid was designed to look into deep, empty darkness, to photograph billions of faint galaxies far across the universe, and map invisible dark matter spread between them. It is, by design, a wide-angle machine. It does not zoom in on single objects the way the Hubble telescope does. It takes in enormous patches of sky in one shot. So for one day, on the 23rd of March 2025, astronomers pointed it somewhere it was never meant to go. They aimed it at the galactic bulge, the dense swarm of stars that forms the very center of the Milky Way. That region is so bright and so crowded that most telescopes are simply overwhelmed by it, flooded with too much light from too many stars at once. Euclid was not. In about 26 hours, it stitched together 9 separate exposures, and each one of those exposures covered a piece of sky larger than the full moon. Line them up side by side and you get the single enormous image filling your screen. Now let me give you a sense of that scale, because it is genuinely hard to take in. Euclid sees about as sharply as the Hubble Space Telescope, the gold standard for crisp images in space. But every one of these 9 pointings covers an area of sky 270 times larger than Hubble can capture at once. Put it another way, to photograph this same region at this quality from the ground, the giant Keck Observatory in Hawaii would need around 2,000 hours of telescope time. Euclid did it in roughly 26. And here's the detail that matters most, the one everything else depends on. Even in the most jammed, light-saturated part of the galaxy, where stars sit almost on top of one another, Euclid can still tell them apart. It can separate one star cleanly from its neighbor, without the whole field blurring into a single smear of light. That ability, holding 60 million individual points sharp and distinct all at once, is the reason this image is not just beautiful, it is useful. In fact, the entire patch of sky that a future telescope called Roman will spend years studying is captured here, in this one frame. Let us go inside the photograph. Start with the dark regions. Scattered across the frame are rivers and pools of blackness, places where there seem to be no stars at all. There are stars there, you simply cannot see them, because between us and them sit vast clouds of cold gas and dust, thick enough to block the light trying to pass through. These are molecular clouds, the cold nurseries where new stars are born, and they carve dark channels straight across the glowing background. The empty-looking patches are not empty. They are the parts of the image where something is standing in the way. Now look for the tighter knots of light, small regions where stars crowd together far more densely than their surroundings. Those are star clusters, families of stars that form together out of the same cloud and have stayed loosely bound ever since. And here and there you will see faint colored glows that are not single points at all. Those are nebulas, sheets of gas lit from within by the young stars buried inside them. One honest note about the color: Euclid took this image with its visible light camera alone, and that camera sees only in black and white. To stay as steady as possible while resolving so many stars at once, that was the right trade. The color you are seeing was added afterwards, using data from a telescope on the ground in Hawaii. So the structure in front of you is completely real. The palette is a careful reconstruction, layered on top to help your eye read what is genuinely there. Buried somewhere in this swarm of 60 million stars are 51 known planetary systems, and the method used to find them is one of the strangest in all of astronomy. It is called microlensing, and it works like this. Every so often, purely by chance, one star drifts directly in front of another, far more distant star, as seen from Earth. When that happens, the gravity of the nearer star bends and magnifies the light of the one behind it, acting like a brief natural magnifying glass in space. And if that nearer star happens to have a planet orbiting it, the planet adds its own tiny lopsided tug to the bending light. That faint extra flicker, lasting maybe hours, is the fingerprint of a hidden world. It is a slow, patient hunt. Over the last 20 years, astronomers have found almost 300 planets this way. And here's the striking part. Every single one of them was discovered from the ground, and every single one was found by looking toward the center of our galaxy, exactly the region in this photograph. The reason is simple. To catch these chance alignments, you need to stare at the most crowded field of stars you can find, because the more stars there are, the more often two of them line up. There's no more crowded field than the one you're looking at right now. And microlensing finds a kind of planet that the other methods miss. Most techniques are biased toward large, hot planets orbiting close to their stars, simply because those are the easiest to detect. Microlensing does not depend on heat or size. It is uniquely good at catching cold, faraway worlds, the ones quietly circling in the dark where nothing else can see them. Among those 51 systems are two planets that the team behind this image cares about more than the rest, because of the stories attached to them. The first is a frozen world discovered 20 years ago. It is so cold and so far from its star that astronomers compare it to Hoth, the ice planet from Star Wars, a planet locked in permanent deep freeze. The astronomer who led the team that first found it is the same person who pushed for Euclid to photograph this region in the first place. He found the planet 2 decades ago, but he's never been able to measure one basic thing about it: its mass. And now, after 20 years, the star hosting that frozen world sits inside this single image, and he's hoping it will finally give him the answer. This second is even stranger. It's a rare system of not one star, but two, circling each other, with a single planet bound to the pair. Systems like that are hard to untangle, because from a distance, the two stars blur together into one point of light. But by taking older images from the Keck Observatory and the Hubble telescope, and combining them with this new razor-sharp Euclid data, astronomers can finally pull the two stars apart, see them as separate objects, and confirm the mass of the planet orbiting them both. Their suns are real points of light, sitting somewhere in the frame, in front of you right now. And now the strangest part of all, the reason this image is a message and not just a picture. To actually catch a microlensing event, to watch one star pass in front of another, and see the planet's signature emerge, a telescope has to monitor that patch of sky for more than 20 days. Euclid looked for one. So Euclid could not discover a single new planet here, and it was never trying to. What it did instead is far cleverer. It photographed all these stars now, sharp and clearly separated, before any of them line up. In the years ahead, the Roman Space Telescope, the one whose entire search field fits inside this frame, will watch this same region and catch those alignments as they happen. And when it does, astronomers can reach back to this Euclid image as a record from the past, a snapshot of exactly how the stars looked before they overlapped. By comparing the two moments, they can measure how fast each star is moving, prove that a planet is really there, and weigh it. That measurement is close to impossible from a single point in time, which is why a before picture is so valuable. That is what this is, a photograph taken now for events that have not happened yet. One ordinary day of looking that has quietly become a fixed reference point. One that telescopes will return to for years to confirm and weigh worlds we have not even found. So let me leave you where we began, looking at the full image all at once. 60 million stars in a single photograph. Now hold on to what each of those specks actually is. Not a far-off galaxy, not a wisp of gas, but a sun, and many of them are not so different from the one that warms your sky. The astronomers who study this region expect almost every one of those stars to hold at least one planet of its own, circling out in the cold and the dark. Now follow that thought. 60 million suns in this frame alone, most of them carrying worlds, and this frame is barely a sliver, one narrow slice of a galaxy that holds hundreds of billions of stars in total. Nobody can point to a single dot in this image and promise you that something is alive on a world beside it. We have not found it. We may search for the rest of our lives and never find it. But sit with the sheer number of suns in front of you and ask yourself, honestly, whether every last one of them is barren. That is the real weight of an image like this, not the 60 million stars you can count, the one hidden somewhere among them that you cannot rule out. Before we leave these 60 million stars, here's your next watch. NASA just released 12 images so sharp they look invented. A dying star firing twin beams into the dark. Worlds caught mid-collapse. We explain every one. It's right there on your screen.